It was magnificent. The Juno probe's mission is coming to an end, but its fate isn't to return home. It's to plunge into Jupiter's atmosphere and be completely incinerated. No one expected that in its final moments, it would capture an image that could potentially rewrite everything we know about Jupiter. This was supposed to be a routine flyby. When the image was transmitted back to Earth, scientists initially saw nothing out of the ordinary. A vast cyclonic system, just like before, with the storm's rotating core at its center. It was only when they switched the image to the infrared and microwave bands that they were stunned. The central storm completely vanished in the infrared. No heat, no structure, not even any depth. It was as if someone had painted a fake storm on the cloud tops. It looked active, yet it had no energy source. It was spinning, but it had no heartbeat. This wasn't just weird, it was counterintuitive. It shattered our physical understanding of gas-giant atmospheres. Previous theories held that such a storm should be filled with internal convective heat sources, with vortex structures layered upon each other. But this image seemed to say, you don't understand anything at all. Scientists briefly suspected an instrument error, but after repeated checks, it was confirmed this was not a malfunction. It was an atmospheric phenomenon never seen before. Some speculate it's a type of super-shallow vortex, sustained by a mechanism we don't yet understand. But for now, the truth remains a mystery. And this was just the first puzzle Juno left us. Over the next 9 years, it witnessed the most powerful volcanic eruption in the solar system, recorded the first ever collision between storms, and discovered bizarre patterns on the surfaces of Jupiter's moons that no human had ever seen. Now, as Juno takes its final bow, let's follow its gaze one last time through Jupiter's sea of clouds and see how many more mysteries await. The journey to Jupiter wasn't just an interstellar trip. It was a 2.6 billion kilometer, 9-year-long space campaign. On August 5th, 2011, Juno launched from Earth. But it didn't head straight for Jupiter. Instead, it flew past Mars and then looped back towards Earth. Was this a malfunction? No, it was a carefully designed gravity assist maneuver. Engineers used Earth as a slingshot, its gravity flinging Juno out of the inner solar system at 26,000 kilometers per hour, straight towards Jupiter. On July 5th, 2016, Juno finally arrived. It didn't enter a conventional orbit, but a highly elliptical one, passing over Jupiter's poles every 43 days. At its closest, it was only 2,400 kilometers above the cloud tops. This was the first time a human probe had gotten such an up-close look at Jupiter from this angle. This orbital design allowed Juno to completely scan Jupiter's magnetic field, atmosphere, poles, and deep structure. During its 9 years, it not only witnessed a supervolcanic eruption on Jupiter's moon Io, but also recorded the first collision between storms and captured unprecedented, mysterious patterns on the surfaces of the moons. But the truly paradigm-shifting discovery came from data sent back near the end of the mission. During its latest flyby, the images and gravity readings from Juno left even senior scientists speechless. It turns out the colored bands we see aren't just a surface coating. They are atmospheric belts reaching a depth of 2,897 kilometers. That's nearly 270 times the depth of Earth's deepest trench. This means Jupiter's atmosphere isn't just clouds. It's a deep system with structure and energy cycles. No other planet in the solar system is like it. Between these bands are the legendary storms, capable of swallowing Earth whole or tearing a probe to shreds. Yet they have somehow spun stably for centuries. Even more during the close flyby on November 29, 2021, Juno practically grazed Jupiter's cloud tops, taking a breathtaking photo. The image showed bright cloud domes suspended above the storms, their cast shadows giving the entire world a three-dimensional depth. The seemingly insignificant white dots in the picture are each the size of a city. This was the first time humanity had seen Jupiter at this resolution. We discovered that the meeting points of storms are not chaotic, but a higher order. They collide and spiral into cyclones hundreds of kilometers deep, forming a dazzling forest of vortices. And the ejected cloud clusters shoot up into the high atmosphere like fountains, 30 to 40 kilometers wide, yet they are still considered minor squalls. With every detail, the planet seems to be telling us one thing: welcome to a world not governed by Earth's rules. The real monster of scale isn't in the movies. It's clinging to Jupiter. Its name is the Great Red Spot. This is a superstorm that could swallow Mercury and Mars, with a diameter exceeding 16,000 kilometers. During its seventh orbital flyby, Juno skimmed right over it, capturing its true face. It was no longer a textbook diagram, but a real, centuries-old rotating monster on a planet. And it's not the only terrifying feature on Jupiter. Every orbit revealed a deeper layer of the planet's madness. Take its south pole, for example, which seems to have been arranged by some strange order. Viewed from 50,000 kilometers up, several giant oval vortices are stably arranged around the center, each over 600 kilometers in diameter, like giant eyes staring at the entire planet. But Juno's mission didn't stop there. Another priority was to keep a close watch on Jupiter's posse of moons. The wildest of them is Io, a world about the size of our moon, yet it's packed with over 400 volcanoes. Plumes of volcanic rain shoot up 300 kilometers, like lava fountains bursting through the ceiling. With Jupiter's massive shadow in the background and fires constantly erupting from the horizon, this isn't science fiction, it's the reality Juno captured. Why is Io so restless? Because it's being needed on a cosmic scale every day. It's in a perfect gravitational resonance with Europa and Ganymede, like three precisely aligned pendulums. This constant push and pull periodically squeeze and stretch Io's orbit, causing its crust to fracture, magma to churn, and volcanoes to erupt ceaselessly. From an ultra-low orbit of just 2,400 kilometers, Juno flew past and captured two volcanic plumes erupting directly from the horizon. NASA even used these images to reconstruct one of the volcanoes, Tvashtar. It wasn't just a volcano, it was a planet-sized fountain. The lava erupted to a height of 330 kilometers, far beyond anything conceivable on Earth. But Io's madness doesn't end there. In 2023, Juno captured a new image of Io's Tvashtar Katina region. Compared to an old photo from the Galileo probe 24 years earlier, the entire mountain has split open, with lava flowing out. It's not a geological relic, it's a fire world deconstructing itself. The infrared spectrometer, GIROM, recorded everything, allowing scientists to create the first volcanic heat map of Io. Every bright spot is an actively erupting volcano. The most astonishing feature is a caldera named Loki Patera, 200 kilometers in diameter, larger than the crater that wiped out the dinosaurs. The entire volcanic lake is covered by a thin crust, dotted with islands, while heat flows beneath. Its surface is as smooth as a mirror, like a giant glass lake in hell. This isn't an exaggeration, it's a direct quote from the scientists. In this clash of fire and ice, it presents a morbid perfection, but there was more to come. Juno also discovered a strange mountain named Steeple, and after two close flybys, its true form was revealed. It looks like a Gothic cathedral carved from volcanic rock, piercing through Io's chaotic landscape. It stands 7.2 kilometers tall. If you were to jump from its peak, you would fall for nearly 90 seconds in Io's weak gravity. On Earth, that's a catastrophe. On Io, it's a scenic view. Io may be the most worthy satellite for study in the entire solar system, not because of its beauty, but because of its insanity. It's like a natural laboratory left by the universe for scientists, laying bare all of planetary physics through its own crust, gravity, and volcanoes. For decades, our understanding of it was based on simulations and speculation. It was only when Juno got close that things started to become real. This wasn't a coincidence. It was thanks to two instruments originally intended for other tasks. The microwave radiometer, MWR, for studying Jupiter's atmosphere, and the GIROM infrared spectrometer. They weren't designed for Io, but engineers repurposed these two eyes to look at its crust, like using a medical CT scanner on a planet's bones and blood vessels. The results were staggering. There is still flowing magma beneath Io's crust. About 10% of the subsurface is slowly cooling lava zones. In other words, Io is like a planet-sized engine with a constantly renewing surface and a perpetually boiling core. Volcanic magma conduits and heat circulate throughout the planet, like a massive radiator that never cools down. It continuously releases its internal heat into space, like a space racing car constantly emitting smoke in a vacuum. But that's not even the craziest part. In December 2024, Io experienced its largest recorded eruption. For 3 whole months, the volcanic plume covered an area of over 65,000 square kilometers, equivalent to the entire nation of Japan being submerged in lava. The energy released was between 140 and 260 terawatts. To put that in perspective, the total power output of all of humanity's power plants combined doesn't even reach a tenth of that. This wasn't a geological event, it was a planetary energy release. NASA scientists are now awaiting Juno's next flyby. It will once again approach Io, coming within 80,000 kilometers, as if to listen to the planet's heartbeat and see if it will erupt with the fury of its entire crust once more. Echoing the revelations from the heart of fire on Io was another shock from Jupiter itself. We've long known Jupiter's magnetic field is strong, but we didn't know how absurdly strong. Juno measured the magnetic field to be over 30 times stronger than Earth's in some areas. This isn't a matter of a compass twitching. It's enough to set off the probe's instrument alarms. So, where does this magnetic field come from? The answer is liquid metallic hydrogen inside Jupiter. This is a strange substance that forms only under extreme pressure. It's both liquid and metallic, capable of flowing and conducting electricity. It is this core of flowing metal within Jupiter that creates the most powerful magnetic field in the solar system. However, Juno's magnetometer, MAG, discovered a crucial detail. This metallic hydrogen layer starts much closer to the surface than previously thought. This means our long-held belief that Jupiter has a solid core and a clearly layered internal structure might be completely wrong. It's not just a planet. It's like a giant, misunderstood reactor, hiding the flaws and arrogance in our very definition of a planet. Juno didn't just validate old theories, it completely shredded a 30-year-old mystery. In 1995, the Galileo probe descended into Jupiter's atmosphere and found the upper layer to be unusually dry, with only a tenth of the expected water. At the time, scientists thought it was a coincidence, that the probe had perhaps fallen into a dry, hot spot. But now we know it wasn't by chance. Juno uncovered the hidden mechanism in the same region. It found that in the equatorial zone, shallow lightning causes water and ammonia to combine into hail-like mushballs. These mushballs, like gas bombs, carry water and ammonia deep into the atmosphere, drying out the upper layers and leaving a misleading impression. So, the 30-year-old mystery was never a misjudgment. We just didn't understand the planet well enough at the time. The most fascinating part of science isn't the answer, but the moment you realize you were wrong. And with every close approach, Juno reminds us that Jupiter is far deeper, hotter, and more defiant of our rules than we ever imagined. Though Juno's mission is nearing its end, it continues to uncover Jupiter's secrets. On April 29, 2025, NASA released new data about Jupiter's south pole and its stationary polar cyclones. This time, the image showed 8 large atmospheric vortices circling a central one, neatly arranged like a ritualistic array around some mysterious core. Each one is over 2,000 kilometers in diameter, roughly the distance from Beijing to Guangzhou. But these behemoths are surprisingly gentle. Unlike Earth's hurricanes, they don't erupt, tear apart, or dissipate. Instead, they persist, spinning stably, almost like a chain of cyclones locked to Jupiter's pole. Scientists use Juno's gyrum and infrared camera to track how they slowly move around the central storm. Under the effect of the beta drift, they slowly approach the center, but push against each other like compressed springs, neither merging nor collapsing, but forming a near-eternal vortex ring. This structure is completely non-existent on Earth, but it's the norm on Jupiter. Juno has shown us for the first time that on this gas giant, weather is not chaos, but some form of order we have yet to understand. In September 2025, Juno will complete its 77th orbit and be directed to plunge into Jupiter's atmosphere, where it will burn up, completing its final mission. 9 years, 77 orbits, countless daring journeys through storms. It brought back not just photos and data, but an ever-expanding list of questions. We thought it would provide answers, but instead, it left us with even greater unknowns.